The MCAT is primarily a reasoning test, but you should expect to get a few questions in which you'll be doing actual math. Now, calculators are not allowed in the exam, but this actually simplifies things because it lets you approximate and round. You won't get answer choices that are so close together that it will be unclear which the correct choice is, and that's intentional on the part of the test designers. The MCAT people don't really care if you can calculate or crunch numbers well, so they make calculations easy on purpose. It's the reasoning that gets you to those calculations that's the hard part. That's what they care about. So with that said, on the MCAT, gravity is a nice and simple 10 meters per second squared, not 9.8. The density of salt water, which you see in Archimedes principle type questions, is normally 1,024 kilograms per meter cubed, but treated the same as fresh water at 1,000. If you get a question like this one, round these numbers to 6 meters per second squared and 2 seconds. Like I said, you won't get two possible answer choices that are, say, 12 meters per second and 11.9 meters per second on the test. The correct answer will be clear, with wrong choices being much more distinct, like 3 meters per second, 9, 18, for example. Okay, moving on to scientific notation and logs. Scientific notation is really easy. When you multiply, you add the exponents together, so you would get 6 times 10 to the 15th on this one. It's just the opposite when you divide. You subtract the denominator exponents from the numerators, giving you 0.67 times 10 to the negative third. Logs are a bit trickier. So when you see log of 10 equals 1, by default we're talking about log base 10. The reason that it's equal to 1 is that logs say, to what power do you need to raise the base to get the number in the brackets? So obviously you raise base 10 to the first power to get 10. Now what if the number in brackets isn't something easy? What if it's 3, for example? Well, approximate again. The square root of 10 is about 3.16, so the log of 3 is going to be about 1/2, as raising something to the 1/2 power is the same as taking its square root. Now, a useful trick you can do with logs is break them up into multiples of the number in brackets. For example, you can break up the log of 30 so that it's equal to the log of 10 plus the log of 3, which is equal to about 1.5. Now you're probably not going to have to calculate logs on the MCAT, but you could get asked a reasoning question based on them. You can see logs in Henderson-Hasselbalch. You can also see them when talking about sound. This equation is the equation for sound level, decibels. Now how might you see this in a question? Say a guy is building a home entertainment system, but it's not quite loud enough for him. So he goes out and doubles the amount of speakers he has, which would double the intensity. So I1 is double I0 here in this equation. Is that going to double the decibels? No. If you had increased the amount of speakers by 10, it would double it. But in this case, it's going to increase the decibels by about 30%. So the big takeaway from logs is that they are a power of 10 system and exponential, not linear. You would have needed 10 times the speakers to double the decibels, and you would have needed 100 times to triple them. So that's logs. Here are some tables you should know. The one on the left are your metric prefixes. These should be second nature to you by now. And remember, always convert to SI units first before you do anything. Then do your calculations and convert back as needed. This lets you stay out of trouble when it comes to equations in which some variables are squared. And the chart on the right has trig values you should know. As long as you have sine and cosine down, you should be good. Remember, tangent is sine over cosine, so that you can always figure out its value if needed. And finally, use units if you're stuck. What I mean by this is, the MCAT is a multiple choice test, and any calculation type question will have answer choices with units. If you can't really remember the formula you need, try to reason it out based on the units of the given values in the question and the units in the answer. This is a trick that has worked for me on physics tests in the past, and I would strongly recommend using it if you do draw a blank on test day. Here I have watts broken down all the way. If for some reason you couldn't remember the formula for power, but you knew the basic units of a watt, you might be able to figure it out based on values given in the question, like a cyclist exerting X force over Y distance for Z seconds. Additionally, learning your units like this should allow you to avoid having to use this trick in the first place, but if you have to, you'll be ready for it. I found this especially useful for learning electricity and magnetism units and their relationships with each other, as electricity and magnetism were just less intuitive for me as a whole. Here I have a farad broken down. This is a little bit more in depth than I learned it when I took the MCAT. I pretty much just learned the relationships as far as joules, and that's probably all you really need, but if you're looking for even more depth, Wikipedia breaks down farads, volts, amps, etc. even further, so check those pages out if you like. Otherwise, that's it. That's MCAT Math.